Jai Hind everyone. In this lecture I am going to discuss about the block diagram reduction. This topic is related to the electronics and communication engineering branch for the subject control system BEC 602. So what is the block diagram system reduction? It is simplification of block diagram by certain arrangements, and we can simplify the results in easy calculation of transfer function for the overall system. So what are the rules for the reduction of this block diagram? So first rule is, if the block is connected in cascade, then we can show the resultant connection with this. If suppose the block 1 is having the gain G1 and the block 2 is having the gain G2, then the overall gain for the system is G1 G2S, where US is the input and US G1 G2S is the output. If the block is connected in parallel, then you can reduce the parallel connection by this. The output will be, the resultant gain for this block diagram will be G1 gain of the block 1 and gain of the block 2. So the resultant gain will be G1 plus G2S. So the overall output for the given block diagram is US is the input and output is here for block output from the block 1 is US G1S and output from block 2 is US G2S. So resultant output is US G1S plus US G2S. So the purpose of reduction of this block diagram is that the output cannot be changed. Without changing the output, you can manipulate or you can get the out. You can reduce the block diagram. So here you can see that US is the input. The overall gain for this block diagram for the cascade for the parallel connection is G1S plus G2S, and the resultant output is same which we are getting in the previous block diagram. Third is feedback loop. So here we have already studied there are two type of feedback connection. First is negative feedback and second is the positive feedback. So here you can see that here this block diagram is, this is a negative feedback system. Here GS is the forward path and HS is the feedback gain, and GS is the forward gain and HS is the feedback gain. So here you can see that after reducing this block diagram, you can get GS upon 1 plus GS HS. So how we are getting this? You are getting this, the output of this feedback path is YS into HS. What will be the output for this block? You will get here YS is equal to GS into US minus YSHS minus YSHS. So the purpose is, what you have to find, we have to find the output in terms of input. So after calculating this, we will get this. After calculating this, we will get GS upon 1 plus GSHS. Similarly, for positive feedback, we will get GS upon 1 minus GSHS. So we can directly write, if I am able to see this, this is the feedback loop and this is the forward, this is the parallel connection, and if this is the cascade connection or series connection. So we can directly reduce with the help we can directly reduce to this form. Now summing point interchange. So here basically there are two summing points. Input is U1 and U2 for the summing point, and for the first summing point, and input is U3 and U1 plus minus U2 for the second summing point. So the resultant output is this U1 plus minus U2 plus minus U3. If I am interchanging these two summing points by each other, then what will we get? U3 will come here and U2 will come here. So the resultant block diagram will be like this. So the output for this summing point will be U1 plus minus U3, and for this summing point will be U1 plus minus U3 plus minus U2. So which is same as this block diagram. So we can interchange the summing point by using this rule. Moving a summing point after a block. Summing point is here. I am going to move this summing point after this block. So the purpose is that the output should not change after moving the takeoff point or summing point after the block or before the block. So here I am shifting the summing point to the after the block. So if I am shifting the summing point to this position, so what will be the input for this input will change. Here you can see that when the summing point is here, the input for this block is u1 plus minus u2. If I have shifted this summing point to after the block, then this input has changed. So now this input resultant output is gs u1 plus minus u2. So if I am shifting this summing point after this block, then we should get the output gs u1 plus minus u2. Then we have to manipulate the gain of the input given to the summing point. Here I am getting gs u1. What is the output? Gs u1 plus minus u2. If I apply u2 directly to this summing point, then I will get gs u1 plus minus u2. So for getting this gs into u2, what we will do, we will use a block of gain gs. So here I have used the block of gain gs to this summing point. So for getting the output equivalent to this output. Next is moving a summing point ahead of block. Moving a summing point ahead of block. I am shifting the summing point to this position. So if I am shifting to this position, so what is the output here? gs u1 plus minus u2. gs u1, if I have shifted this summing point to this position, the resultant input for this the resultant output for this summing point is u1 plus minus u2. If I am shifting directly, so what is the desired output here? gs u1 plus minus u2. For getting this desired output, if I am using only u2 here, so what will I get? u1 plus minus u2 multiplied by gs. But the objective is that we have to get gs u1 plus minus u2. So for getting u2 only, we have to divide the gain by, we have to use the block diagram of having inverse gain of the forward gain. Moving a takeoff point after a block. Moving a takeoff point after a block, I am shifting this takeoff point after the block. If the takeoff point was here, then the output of this takeoff point is u. If I am shifting this takeoff point at this position, then I am getting there us into gs. For getting this output u, I have to divide this output by a gain gs. After that, or you can say I have to use a block of inverse gain of the block. After that, you are shifting a takeoff point. Now moving a takeoff point before a block, I am shifting this takeoff point to this position. So you can see here us is the input, gs is the gain of the forward path, the output is us into gs, your takeoff point is here, so the output from this takeoff point is us into gs. If I have shifted this takeoff point to this position, then what happens here? If I have shifted this without this block, then the output is u, but the output should be u into gs. So what I have to do, I have to multiply, I have to use a block of gain gs for getting this u into gs. Moving a takeoff point, next rule is moving a takeoff point ahead of summing point. Ahead of summing point, takeoff point, I am going to shift this takeoff point ahead of summing point. So you have to see here, u1 and u2 is the input. What is the output of this summing point? u1 plus minus u2. What is the output of this takeoff point? The same output of this summing point is the output of takeoff point and the desired output. So the desired output and output of the takeoff point is same. If I am shifting this takeoff point to this before the summing point, then what will I get? I will get here u1. What should I get? I should get u1 plus minus u2. For getting this u1 plus minus u2, I have to use a summing point with the input u2. Then you can get the output y as a u1 plus minus u2. And this u1 plus minus u2 is same and the output is same. So the output of the block diagram or output of the takeoff point is, output of the summing point is same, but the output of takeoff point will change if I am not going to use this summing point after the takeoff point in the connection of takeoff point. Similarly, moving a takeoff point beyond a summing point. So I am going to shift this takeoff point after the summing point. If I am shifting this summing, if I am shifting this takeoff point after the summing point, then I have to use another summing point for getting the same output, that is U1 plus minus U2. Now coming to the rules for reduction of the block diagram. So first rule is that check for the blocks connected in series and simplify them. After that you have to check the blocks connected in parallel and simplify. Rule 3 is check the block diagram connected in feedback loop and simplify. If there is a difficulty with the takeoff point while simplifying, shift it towards the left, towards the right. Why you are shifting this takeoff point to the right? Because standard or you can say canonical form of this is like this. Of the closed loop control system is this. The input is output. So takeoff point for this, for any block diagram of any closed loop system should be in the right of the blocks and summing point should be in the left of the blocks, so that you can easily simplify the you can easily simplify in the form of closed loop canonical system or closed loop control system. So rule 4 is saying if there is a difficulty with the takeoff point while shifting, shift it towards the right. By shifting the takeoff point towards the right, you are approaching towards the closed loop control system, or you can say in the canonical form of the closed loop control system. If there is a rule 5 is saying if there is a difficulty with the summing point, simplify it, and simplifying, shift it towards the left. The purpose of shifting the summing point towards the left is that you are approaching towards the simplifying, or you are approaching towards the closed loop canonical form. So by using these rule 1 to rule 5, you can easily simplify or you can easily reduce the block diagram given to you. And if you are unable to reduce this block diagram, you have to repeat these rules multiple times. Now let us take an example for reduction of this block diagram that you have studied in this lecture. I have already told the rules, I have already told the methods for reduction, and after that I have told you the rules for the reduction. Now I am taking an example for reduction of block diagram using those rules and methods. So in this block diagram you can see that first you can see that there are multiple connections. So I will start with this by shifting the takeoff points before block G2. So here you can see, here the summing point is in the left, summing point is in the right, this takeoff point is in the right. So if I shift the takeoff point before the block G2, before block G2, if I am shifting this takeoff point before the block G2, it means I am shifting this takeoff point this takeoff point, I am shifting this takeoff point before the block G2. If I shift this takeoff point before the block G2, then we have to multiply this with the block gain of with the gain of the block to which you are shifting before. So it will become H1G2. Next, in the next step, I will shift the takeoff point. I will shift the takeoff point before the summer. So where is the takeoff point? This is the takeoff point. I am shifting this before the summer. So after shifting this before the summer, what will happen? A summing point will introduce here, and this summing point will go there. So resultant block diagram will be like this, and after then you can shift the summing point summer block ahead of block G2. This is, we can shift this summing point ahead of block G2. So for shifting this ahead of block G2, what will you do? You have to add the gain, block of gain G2. Now you can see, for getting this resultant output, we have to interchange. For getting this resultant, how will you get the resultant? If I interchange these two summing points, I can easily reduce these two connections. It means they are connected, they will be connected in parallel. and here you will get the standard canonical form. So what I am going to do, I am going to interchange the summing point. By interchanging the summing point, you will be able to see here that this is the parallel connection and this is the standard canonical form of the closed loop system. So what will happen? You can write, this is the parallel connection, so I have reduced in the form G2 plus G3. This is the standard connection, this is the forward path of gain 1. So you will write here 1 upon, these two are connected in series. So G2H2, you will get here, this is the negative feedback, you will get here 1 upon 1 plus G2H2. So you will get here 1 upon 1 plus G2H2. And this is connected with the summing point, this is the summing point, here this H2. This H2 is connected with this feedback path and this H2 is connected with this G2. So there will be two connections, G2H2 will be in series and this will be connected, this H2 will also be connected with this summing point. So here you can see G2H2 is connected in series, G2 and H2 are connected in series with this summing point and H2 is connected with this summing point. Now, you can see here, I am going to split this summing point. What is going to happen? This is the summing point, this is connected to this. So, I am going to take the another summing point, G1 is connected with this and G2H2 is connected with this summing point. So, I am going to shift, if I am shifting this summing point to this position, I have shifted this summing point to this position. So, what will you get? G1 H1 G2 and G1 H1 G2 H2. See here, G1 H1 G2 and G1 H1 G2 with G1 H2 G1, H1 G2 into H2. These are connected in series, this is connected in feedback. So what happens here? G1, this H1 G2 is connected in feedback, this G1 H1 G2 is connected in feedback. Now you can further reduce this, you can see here, this is the standard canonical form and this is the, this standard resultant of this reduction of block diagram is connected in series and this is again the standard canonical form. After that you can reduce to the standard canonical form. Now this is G1 H1 G2, G2 plus G3, 1 upon 1 plus G2 H2 and this is connected in the feedback path and this is connected in the G minus G2 H1 H2 is connected in the feedback path. Now after reducing this you will get here G1 upon 1 GS upon 1 plus GSHS, G1 G2 H1. You will get here G1 upon 1 plus G1 G2 H1 in series with G2 plus G3, in series with 1 upon 1 plus G2 H2 in feedback of this. Now you can easily see these three blocks are connected in series. So the resultant of this will be G1 G2 plus G3 1 plus G1 G2 H1 1 plus G2 H2 and G2 H2 is connected in feedback. So the overall transfer function for the given block diagram is, similarly we can do another example by using these rules and techniques for reduction of, we can use the block diagram reduction methods for reduction of block diagram. Thank you.